first of all we have done this thing like सबसे पहले जो हमने किया था it was a one task, right, with a servo motor in FreeRTOS, along with one task with a PWM, right? So I think this was the third step, right? Oh, okay. The first step was understanding about the FreeRTOS. What is the FreeRTOS? What is the task? What is the queue, right? And how we can do this? And all kind of the setup of CubeMX, setup of Qt, setup of Cube IDE, right? And the installation and examples, right? So we have done this thing. So we have developed the 3 tasks simultaneously over the STM32, and then we tried ADC with a separate task, right? In that we created one task to read the analog value from the STM32, and after that we have tried the same thing, that means FreeRTOS task over the PWM with servo motor. And I have given you an assignment which was running servo motor with ADC, right, potentiometer. That was the one assignment. And after that we have jumped over the fifth step, that was the binary semaphore. Right, it was fourth step inverse, which was the queue. How we can use the queue by for the especially data management with accuracy, in which what we have done, we was taking the data from ESP32, right, and putting that data on the queue through one task, which is one dedicated task which was putting all the data into a queue, and then another task was fetching the data from the same queue and displaying over the console of STM32. Okay, so this was the LED display, LED task. Okay. Yeah. Then fifth section was binary semaphore, which we have got that how we can use the push button without any while loop or any task. Directly we can wake up the CPU or task whenever we are getting update from the interrupt service routine ISR through the push button. Okay. Then next was, today we will cover Mutex. Okay. So actually we have already taken too much time, especially for the STM32. Okay, so I think today we have completed this Mutex part, right, OLED, along with I2C. This was the plan, because if I told you the separate thing, PWM, ADC and DSC and all these things separately, then after that I have, when we switch over the this FreeRTOS part, our time will get consumed like in 2x. So that's why we got with this idea that let's combine PWM, ADC, DSC and everything along with the FreeRTOS. Okay. So I think we do not have covered yet I2C. I think we have covered I2C in ESP32, right?
Yes.
Yeah, ESP32, but not with the FreeRTOS and not with the STM32. So today we will cover I2C with STM32 along with the FreeRTOS, right? And the concept of the FreeRTOS that we are going to use in this, especially in this session, was it is a queue. It's not queue. It's a Mutex. So last time I have given one example of Mutex. What is the Mutex? It's kind of access control system. Let's say there is one single door, and there is only single key for that particular door. So only one person can open that door with that key. Okay. So let me give you one case study of our office. So every day, let's say I have an office and there are multiple employees, but key is the single. Okay, there is only one key. So only one person. Rahul, can you mute yourself here? There is a little bit noise. Okay. So let's say there is a about Mutex. Okay, so first of all, what I was giving an example of a access control system. That means, let's say there is a single door of office and there is multiple employees to open that gate, right? मोस्टली हमारे ऑफिस के अंदर होता है कि जो पहले आ गए उसको की ज़रूरत लगती है, राइट. सो इन दैट केस हाउ वी विल मैनेज दैट, देर इज़ अ वन की, राइट. विल कीप दैट की इन अ सिंगल प्लेस, कि जो भी पहले आएगा उसकी का यूज़ करेगा एंड that person will open the door, right. So in the mutex we'll also use the mostly similar concept, that if one task is has a mutex, right, only that task is running. It is about the sharing the resources, sharing the, like we are sharing the key with other persons, right. कि अगर आपके पास की है तो आप भी ओपन कर सकते हो, आपके पास की है तो आप भी ओपन कर सकते हो, राइट. सो इट इज़ अ शेयरिंग अ सिंगल रिसोर्सेज विद मल्टीपल टास्क, right. That's why we have taken the example of I2C. So let's say there is a one I2C bus, right, and one task is using that, right. So if one task is already using that I2C bus, right, it is not allowed that other task can use that simultaneously, right. So that's why we are sharing the I2C as a resources with multiple tasks. But for that we have to give the access control system, okay, that for particular this time to this time only this task can use the I2C bus, and another particular of time then task B can use that, right. So right now we are using a shared resources. So today we'll implement I2C as a shared resources with Mutex, a FreeRTOS concept, right. So okay, you can see on the notes. So the problem is two tasks, one display, no protection. Okay, you have an OLED display, two tasks want to write simultaneously without protection. So that maybe create a issue, right. Right, maybe other tasks can override the existing shared data over the queue, or the data into the pipeline of I2C. Okay, so scheduler can interrupt task 1 between set cursor and write things. Task 2 write a different position, I2C get corrupted, right. So what will be the resulted, like data may be you can get the data as a garbage value, right, or maybe we can get some random data over the display, or maybe it get stuck anywhere between the program or action, right. So mutex, before writing OLED, take the mutex, right. Whenever one task want to write something on the OLED, it has to take permission as a mutex. So after writing that, give mutex will give, that means if you have done with the writing, then give the key again, that means return that key or return that access, so that other task can use that. So only one task can hold mutex at a time, other task will wait, right. I2C transaction will complete safety. So this is the mutex, is a mutex mutual exclusion, right. This is the maybe name of mutex. That means mutual exclusion. It is a lock, only one task can hold it at a time. If task A is holding the mutex, task B wait, when task A release it, task B get it. Shared resources accessed by only one task at a time, right. This is a image or a drawing for like how you can how multiple tasks can access the same resources. And this is the difference between the binary and semaphore, right. So we'll use semaphore for signal between ISR and task, right. It is for like kind of updating the things, right, that I have some kind of data, news, or pending task, right. Then it will update, then task execute. This is the case of semaphore. Mutex is about protection, right, share with shared resources. And semaphore is allowed any task or ISR can use it, only a single task can use it, right. Example we can take as a button press or event signaling. Or for mutex we can use in case of where we have limited resources like I2C, SPI, and other things, right. Priority inheritance, in this binary semaphore there is no kind of things, no priority or inheritance, right. But in case of mutex we can use we can set the different kinds of priority for it, right. Which task will get mutex first, right, over the priority, right. So you can assume this example also, a single ATM machine, right. There is one ATM, right, and there are different kinds of purpose, there are different kind of person who want to get the money, right. But we can say that right, we have seen multiple times only one person can access the ATM at a time, right? So that's why the other person has to wait until the first person will get completed its work. So ATM machine is a good example of Mutex. This is the hardware connection that we are going to use for the I2C connection that last time we have connected. So OLED VCC pin will be connected over the 3.3 ground to ground, and for SCL we'll use I2C1, right? In I2C1 there is a dedicated pin, port B pin 6, port B pin 7, right? So B6 and B7 of port B will be used as the SCL or HDA pin, okay, and we'll use 3.3 not 5 volt, okay. So before that, but you have to download this library, right? I think last time we have done this in ESP32, right? And we have updated, like I think last time we have done this through CMake file, I think, but there is a not CMake file that we need to add here. What is very simple to add, we will include all the this .h file into our dedicated folder, that is include folder, okay, of STM32. Okay, so yeah, so before that starting the projects, do one thing. First of all, download this library. This is the GitHub library. Click on the code, right? Click on the code, download the zip and unzip this folder, okay. After unzip that folder, I think you should get folder like this. Where it is, this is the folder, okay. You will get a folder like this, and from this folder there is example SSD 1306. Here what you have to do, you have to copy paste this thing. I think not all the files is necessary, right? But you can skip this two file, test and test.h. You can copy other files, right? But it's much better, do one thing, skip this part, because in that part you have to maybe change the name of the things, okay. It's much better. I think this project already has a link, GitHub link right here, because in the file it should be not a template.h, right? It should be ssd306 config.h, right? So do one thing, it's much better, instead of copying the .h file, you can download this project. This is our project, right? If you check in this project, in the core and in the including for in each folder, there is we have added library files, right? .h file like ssd306.h, ssd306 conf.h, and this is font.h, right? This is the three important file for this thing, right? Because in this one of the file we have to set that STM name also here, right? Here, like right now maybe by default in the other library this is enabled, right? First thing, but because we are using STM32 F10, right? So we have to enable this thing. So for to save the time, you can directly download this project also, okay. But still, please check on the screen, right? Let me complete this all the methods, right? So first of all, we'll download the library. We'll include all the library that means .h file into our project folder, and after that we will start a project from CubeMX, right? In that we'll first initialize the I2C mode, right? In this we will set the parameters like mode of communication, and the dedicated pins already there, P6 and B7. Then we'll initialize FreeRTOS, right? And the directly generate code. You can skip this step. You do not need to create the task manually from the CubeMX. Okay, so yeah, and I think you already got the code from the GitHub, so you do not need to copy paste directly from here. Yeah, and you should get some kind of output, right? And what is the concept behind this output? Let me explain in the code. So this is our CubeMX. Let me open up the prod project. Load project. Okay, so when you have done with creating a new project in the MX Cube, when you go for the connectivity, you will see here I2C1, right? And I2C1 will enable I2C, and here you can check your parameters should be like this. I hope these are the right. I think this is already a default parameter, so I don't think that you have to change much here. And you can check the dedicated pin for the I2C here, PB6 and PB7, right, for SCL and SDL. In the project manager, give it a name and select the STM32 cube IDE from here. Yeah, and do not forget to enable the FreeRTOS, in which we'll choose the version 1 of the FreeRTOS. Okay, yeah, and after that you can generate code. And when you have generated this code, you should get one project in your STM32 IDE. Okay, so let me know if you have done here. Then we'll check our code. The main code is in FreeRTOS.c. यहाँ तक किया आप लोगों ने सबने?
Yes, Paul.
यहाँ तक हो गया आपका?
मैं in a different call, but yeah, मैं कर रहा हूँ parallelly. I'm just doing slowly. Yeah.
Okay. Okay. First of all, let everyone be in the same stage. Okay. Just download the project and open here. Then we'll understand the actual working of our code and task. And let me know if you have done. See exactly, ठीक है? Then होना चाहिए आपके पास SSD06 font.h and SSD06.h. ये तीनों फाइल इधर होना चाहिए, दो फाइल इधर होना चाहिए. लेकिन लाइब्रेरी आप ओपन करोगे यहाँ पे तो आपको ये किसका नेम गलत मिलेगा, ठीक है? आपको करेक्ट करना है. टेम्पलेट हटा देना है यहाँ से, conf.h होना चाहिए सब. main.c और FreeRTOS.c GitHub से ले लें, ठीक है? Okay, model. This is the model. Yeah, Mutex. Rahul, have you done that?
Yeah, Paul, can you share that library? OLED library.
Okay. This is the link for the code, and let me share the link for the library. This is the link for the library.
Pawan? Like in FreeRTOS.c file, there are lines that include FreeRTOS.h, task.h, and your.h. That I'm getting error.
You are getting these things are not included.
Yes, but it is not. It is different actually. It's a copy from website.
Have you created the project?
Yes.
Your project should be new. What you have to copy just FreeRTOS.c, but your project should be completely new. Do not just download complete project from the GitHub. Create a new project through the QMX.
Okay. So I need to copy the file from the GitHub. Only FreeRTOS.
Yes, no, do not copy complete project because
Yeah,
in
got
the
it.
from the QMX you have to enable a few things like FreeRTOS and things, right?
Yeah, got it. Actually, I copied the
Okay.
script from the website.
No, create a new project and then first of all build that project if it's that building a normal project, then copy this file freerto.c main.c and the files related to the display.
Okay.
Sumit, are you there? Okay, Subika.
Yes, one is.
Okay, so give attention to the code. Open your freerto.c. Let's understand the first of our task. So here, our first task is the start display, right? So in this, what we are doing, we are first of all checking that our mutex is created or not. Okay, and if our mutex is created, right, then after that we'll initialize all the settings related to our OLED model, that is SSD 136106. Okay, and yeah, this is our actual task that is started from the while loop here. So this is the actual command for our instruction for the semaphore, right? That means here we are checking that the mutex is checking like if other task has already hold the mutex, right? So here we are checking that mutex should be open to tech, right? If it is not available, that means mutex is not available. What is the mutex? Is already mutex, right? If you click here, then you will that mutex has defined, right? Here we have defined the mutex in the semaphore handle, right? And we have initialized with that null value, and this is the shared variable counter, right? This is used by task. So here, first of all, we'll check that mutex should be empty, open, right? If it is available, then it will execute this instruction. Otherwise, not. Otherwise, the warning that mutex timeout already update is skipped, right? Because it has certain time limit. What is the time limit for that? Here. Then, if you closely check other task, we have another task. Whose name is start counter task. Here again, we are doing the same thing. Here we are checking that already mutex is available or not, right? With the same command. First of all, we are checking this is the instruction for checking that it is created or not, it is available or not, and this is the instruction that is checking already the same mutex that it is taken or not. So if it is free or available for use, then here what we are doing is just simple the way we have initialized earlier for this loop, that was the counter. We are just incrementing that counter, right? And yeah, and after incrementing that, we are also leaving that semaphore. Oh sorry, mutex. We are leaving that. Means we have just used that mutex, and now we are also making it free to use for other, right? If it is not available, otherwise it will jump to the in the else case. So logic is very simple. So if you understand here, let's say this task already task has a mutex, right? So if then the program will enter here, it will first of all fill the LED with a black screen, then it will print the counter here. It is a global variable that is shared by both tasks. So here what we are printing after setting the cursor, we are writing the counter, right? This is a variable, and it's a value that we are writing. And if you know, this function is very famous instruction, sprintf. But for what we use this as sprintf, I think you have seen this function too many times in mostly C programs, in C programming. That means we are wrapping the things. That means that the characters and the integer value, we are combining two different data types value into a single variable. And what the type of variable is character, right? That means we are putting this thing, this counter variables value and this characters into a single variable into line one. Okay, and here you can see that in the to this function, right, string, because this function support as a string as an argument. Okay, so here we are passing the same variables value. And what is the total value of this variable? This and this counter value will be replaced here. So here we are writing the string through this instruction, write string, and after that we are taking some counts from the timer, and yeah, again we are printing here line 2. This is the line 2, and I think what should be in the line 2 should be up and up time. That means here we are printing time print. We are printing time in the seconds, right? Then most probably we'll see the difference between this because right now we are there are two different things but very minor difference. What is this counter variable is controlled by this task, right? And in this in this instruction we are not taking any variable from another task. This variable uptime, it is directly created here and directly printed here, so it will not take much time, right? But this counter variable is controlled by other task, so it may be you will feel some difference, right? Because every task has their own maybe even it's in milliseconds, but it has delay, right? So again other things are very simple. We are printing just a few comments below to this timer and uptime variables, and we are updating screen, and here again we are leaving the semaphore to use by another task. Okay, simple, right? So right click, build the project. If it's built successfully, debug this application. But before that, you have to connect the wires, right? So let's first of all focus on that part. What we have seen in our notes, that we have to find first of all pins, port P6 and port B7. Here we can find it is our PB6, right? This is, you can see it is like available 1, 2, 3. That means at this pin it is available PB6 nearby the D10. You can see the D10 on your board. So at the PB port number B6. Okay, here you can see this B6, and I think it is a PB7 here. This nearby the, but it's outside, not inside. Okay, it's a PB7. Keep remember there are two different worksheet. So this worksheet is 21 is a PB7, and here you can find the ground, and here you can find the 3.3. Give the VCC the 3.3, give the ground, connect both pin, and do not forget ulta nahi karna, okay? Remember PB7 is a SDA and PB6 as a SCL. Okay. Anyway. Okay, so first of all, let's make the connection, and after that, flash the code, and let me know if you have work. Just take the photo, video, whatever you can, and post into the group. ज़्यादा लंबा नहीं बनाना है, एक मिनट 2-3 सेकंड 3-3 सेकंड हो जाएगी वीडियो में, ठीक है। वेट एक सेकंड इसका जो क्लोज सर्विस कितना काउंट होगा।
इन वीडियोस को कंटेंट
वर्किंग चला किसी का